Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, let's go over some of the output tube wiring we've done since the last video. And I kind of went over what we were going to do because it's easier to see when the wiring's not in place. But here's what it looks like after it's wired. So we're using pin 6, which is unused by the tube, as a tag point for this ultralinear screen wire. So the ultralinear tap, which is this white with the blue stripe, connects to the upper hole in pin 6, and then in the lower pin we put this 1.2K resistor between pin 6 and pin 4, and then I just trim off the upper hole on this pin because we're not using it. And then we do the same thing over here on this side, mirroring what this tube looks like. We've got the 40% ultralinear tap going to pin 6 in the upper hole, and then across the two lower holes we have this 1.2K resistor, and then we connect the plate lead up to pin 3 on both sides. We've also installed the cathode bypass cap, and it's going from this lead, which is the positive side of the cap, which is where the cathode is connected to, from here to here. Then this is the positive side. This cap goes to ground. And then over here on this side we have the same thing. The cathode lead here on the tube runs up, connects to this pin, and then this is the positive lead that the cap connects to, and that's the ground that the negative goes to. So we have our cathode bypass caps in place. The resistors are all wired up to the cathode. We have the 1.2K grid stopper that goes from pin 5 over to this terminal. And we put a little PTFE tubing on the lead to just reinforce it a little bit and have a little insulation. I'll link this stuff in the description. It's easily found. It's used for 3D printing, and so stuff's not hard to find. Same thing over here. We've got a 1.2K resistor going from the grid of the tube over to this terminal. I'm using the lower hole in this terminal and then snipping off the top of it because we're not going to be using it. And then while we had the 1.2K resistors out, we came in here and wired up the grids of the input tubes. So we're going from this terminal to this middle of these three terminals. This is the plate, that's the cathode, the center one is the grid. And again, put the body of the resistor as close to this pin as you can and have the excess lead on the other side. And then on this other triode, again, we have the plate, the grid, and the cathode. The center one is the grid. 1.2K resistor from this terminal across here to this pin. And let me roll the amp up and show you what this looks like in 3D. And as you can see, I have this kind of come up and then across to keep it away from this 6.3 volt heater as much as possible. And it kind of goes around the edge of it anyway. It's not directly going over the top of the wire, so shouldn't pick up any noise at all. But again, just come up, looks like maybe 1/4 of an inch, and then go across so that this wire is level. And then this one over here is not a concern because it's not anywhere near the heater. And then for these transformer leads, they come up and over and across the top of these, and leave a little space in here. We've got plenty of room, you can see, between here and the bottom of the amp. So just have these loop up and come down to the tube sockets. And then you can see how these grid stoppers just come from the grid of the tube over to this terminal, and then from the grid of this tube to that terminal. And let me get one more angle on this for you. And here you can see the ultralinear wire comes in, and then this is the 1.2K resistor going across those two terminals. Same thing on this side. Ultralinear tap comes in, and we have the resistor across these two terminals. And here's our grid resistor. This is the plate, and then here's the other grid resistor. The last thing we did, and this goes back to our layered approach to wiring this up, is this is our plate load resistor for the front end tube, and it's going from the lower hole in this terminal, little PTFE tubing. There's the resistor that connects to this terminal right here. And the same thing on this side. Goes from the lower hole. Remember I mentioned that we need to have access to that. So you make sure this positive wire is down a little bit so you can connect to this lower hole. And it comes across and connects to this terminal. And I think that gives it a really neat layout. Let me see if I can show you. So now we're at the point where we're ready to power up this amplifier and start checking our plate and cathode voltages on the output tubes, as well as the B plus over here coming out of the power supply. So you'll be checking the voltage here. You'll be checking the voltage here and here, which are the plates of the output tubes. Let me zoom in here so you get a little better view of this. I'll show you checking the voltages on these output tubes. So the key voltages to check on the output tubes are, you want to check the plate voltage, which is here and here, this blue wire to the tube. Then you want to check the screen voltage, which is going to be at this point, not at the wire, but here. And then you want to check it here. And it should be a few volts below the plate. That's what we're shooting for. And then the final thing you're going to check is the cathode voltage, which is the bias. And you can check it right here on this wire or this terminal. And then you can check the other tube here. So this one will be for this tube, and then this check will be for this tube. And here's the schematic that shows all the voltages that you should be seeing. And again, we haven't completed the wiring on the front end, but it draws such little current, it's probably not going to have a measurable impact on the voltages. You might see a couple of volts change, but the output tubes draw the majority of the current, and so that's what you're going to really see now is the true voltages when you have the rectifier tube and the output tubes in place. And you can put the input tube in as well, or the driver tube, and just make sure the heater's working at this point. Obviously, if you've never done this kind of a thing, you need to make sure you understand how to do this safely. One thing I recommend if you're new to this and you don't feel real comfortable being inside of a live tube amp is to simply use alligator clips on your test probes and power off the amp between each voltage test. So you can clip either here or here. This is going to be a ground, and then clip on to this lead, power the amp up, check the voltage. Turn it off, wait till this voltage goes away as seen on your voltmeter. Then move it over to this point. Power the amp back up. Check it again. Also, give the amp a little time between the power off and power on so you get all the voltage drained out so you don't kill the rectifier tube, because they don't like hot starts either. But moving further through the amp, then you can put a clip onto this terminal. Same thing here, you can clip onto this terminal right here, check your screen voltage on both the tubes, and you clip on here to check the bias on this tube, and then clip here, check the bias on that tube. Again, if you haven't done this before, please read up on electrical safety inside of a high voltage amplifier. I do not want anybody to get electrocuted working on this stuff, and this voltage is deadly. It can kill you. So I know that sounds kind of extreme, but I just want to be overly cautious and not have anybody harm themselves working on this stuff. So once you've checked all that out and all the voltages look good, we're going to move on to finishing the wiring on the front end of the amp. And what we have left to do, we need to set up the RC, or resistive capacitive decoupling circuit, that's going to power up the front end too. So the first thing we're going to do is put the 4.7K dropping resistor that goes from here to here, and I would put it like right here on this side of this tag strip on these upper holes. Same thing over here. We're going to put a 4.7K from here to here, goes across those two terminals, and we've already got our plate load resistor installed. So all that's left is we have a 33 UF cap 500 volt that goes across from here to here. Obviously this is the ground, and it's going to sit like right here. Another one's going to sit right here that goes between this positive and ground, and that decouples the power supply for the front end tube from the rest of the amplifier. The next thing we need to do is we're going to run a wire from this terminal, which is the plate, over to here. And then we're going to run another wire from this plate over to here. So again, from this point, it comes up and over and across, and you can go up a little bit to keep it away from this heater wiring because it's going to cross it. So come up, over, and down. And then this one can just loop like this. Then on the cathode, we're going to put our 160 ohm resistor from here to here. Then another 160 ohm resistor is going to go from here to here. And then finally, we have our red LED that goes from this terminal to here, across these two fixed points. And then the same thing over here, got an LED that goes from here to here. So the cathode circuit will be through the 160 ohm resistor, then through the LED to ground, and the same thing here, 160 ohm resistor through the LED to ground. So once we make sure that all the voltages on these output tubes look good, I'm going to go ahead and wire up the rest of this front end component wiring, and we'll come back and show you what that looks like, and then we can get to work on finishing up this amplifier. Okay, so we power the amp up to do our initial voltage test. This is the first test point that you're going to check. This is the output of the power supply, and you should see about 430 volts here. Now the voltages may be plus or minus a few volts. It's not like written in stone that's going to be exactly 430, because there's some variables on the rectifier tube and the transformer and all that kind of stuff. So somewhere around 430 is what you should see on this terminal. And this is with the rectifier tube and the output tubes in the amp. Then the next spot we're going to check is the output tubes themselves, where this blue wire connects. This is the plate. I saw 424. And then where this resistor connects to this terminal, 419. You want to see about 4 or 5 volts less than the plate on the screen. Same thing over here. We got 424. And then on the screen here, we had 419. Next place to check is right here. This is going to be the cathode. I mean, you can check it right there too. It's the same deal. It's going to get the same voltage. It's just easier to check it up here. This was 31 volts, and this one here is 31 volts. So We had identical voltages there, so powered the amp off, made sure that the voltage had all drained off of the capacitors before we went back in and started doing any more work. And then we got the front end all wired up. So like I said, 4.7K between this terminal and this terminal on this side of the tag strip. And same thing here, 4.7K. We're doing them on this side of the tag strips to keep the heat from this away from this capacitor as much as possible. And then we put these two 33UF 500 volt caps, and it goes from this terminal here, the positive of the cap, and then the negative of the cap goes here. Same thing on this side, positive of the cap there, negative of the cap there. And they're going to look like this when they're installed in the amp. And you can see they're fairly tall caps, so you need to mount them fairly close down to this tag strip so we got some room here for the bottom cover. You don't want to have them sticking up too high. You want to mount them as close to this tag strip as you can, and the leads come out kind of at a 45-degree angle to each other. Let me get a cap and show you what that looks like. You're going to bend the leads over like this, and then they just go through the holes in the tag strip, and then you bend them over and solder them in place. And they'll sit just like that. If that makes sense? So anyway, then we came down here to the front end driver tube of the amp, because we have these plate load resistors in place. We now have the voltage up to what will be the plate terminal, which is right here and right here. And as you can see, I ran a jumper wire from the plate. It goes up, over, and down. And then this one, it just curves around and comes over here and connects. And both of them are to the top hole in the terminal strip. And this one looks like this. Goes up, over, and down. Then the last connection is going to be this 160 ohm resistor that goes from this cathode terminal to this terminal on the tag strip. And then you can see we soldered our LED from this terminal to ground. And then on this side of the tube, let me prop this up so you can see that a little better. On this side, you're going from this terminal on the tube, which is pin 3, and it comes across and goes to this terminal on the tag strip, and then we have our LED that goes from here to ground. And that's it. That's got the front end of the tube all wired up, so we're ready to power the amp back up and check the voltages here. Now they're going to be a little bit lower on the plate than the schematic shows until you hook up the shade feedback resistor, but that's nothing to worry about. You want to see about 1.8 volts or 1.7 volts here on the cathode, which would be on this terminal right here, and that terminal right there. And when you see the LEDs light up, you know that things are cooking like they're supposed to. I'm going to put on the little note card here what this voltage is supposed to be without the shade feedback resistor, just so you know that that's all working right. So all we have left to do now is hook up the shade feedback resistor, which is a 3 watt 360K resistor. It goes from this terminal here where this blue wire is hooked up, which is the plate of the output tube, and it's going to go around here and hook up to this terminal right here, which is the plate of the driver tube. And then on this channel, same thing, we're going to hook up a resistor from this terminal on the plate to this terminal right here, which is the plate of the driver tube. And then finally, we're going to install the coupling caps. and they go right here. And that's their spot. Got to have a fairly long lead from here to the coupling cap, and then bend it over at 90 degrees and hook it up to here. Going to put some PTFE tubing on the leads of these as well. And then the other one sits in the same spot. I have to bend the lead over to really get it to sit in the right spot, but it's going to sit over on this side of the amp in that same little area right in here. And now I've designed this amp with the idea that in the future, some owner may decide they want to put one of these larger size like Miflex or Jupiter caps as coupling caps to try them out. And so I left a fairly large area here and here that has room to put one of these big caps similar to this one. Can sit right there. And you can figure out a way to route the leads to install some of these larger caps and maybe hot glue or double stick tape them to the chassis there, and then bend the leads over and insulate them however you're going to. But that was kind of the idea. And there's actually room to put one over on this side of the amp as well if you wanted to. It's going to be a tight fit, but they will fit in there and still have a volume control. So anyway, let me go ahead and get these coupling caps in, and then I can start working on the volume controls. I need to talk to the owner or the future owner of this amp and see how he wants it configured, and we'll come back and install some RCA jacks and a volume control and the coupling caps along with the shade feedback resistors, and this amp will be ready to go listen to. So I hope you're enjoying this content. If you are, please subscribe to the channel. Please like the video. Thanks to all you folks supporting the channel and your interest in purchasing these amps. They really are nice sounding. Hopefully you guys that are DIYers will build some of these or build one for yourself and enjoy a really nice sounding amp. And until the next video, have a nice day.